the directions of the force can be determined by Fleming's left-hand rule. So according to Fleming's left-hand rules, so there are two factors that affect the directions of the field. One is the current. Another one is the directions of the magnetic field. Directions of the magnetic field. Now, magnetic field, the magnetic field always moves from north to south. North to south. Current is always from positive to negative. So you use your left hand. Okay, then use your thumb, your index fingers, and the middle fingers. Okay, so the thumb represents the directions of the force, and the index finger represent the directions of the magnetic field, and the middle fingers will represent the directions of the current. These three fingers are at right angles with each other. They are at right angles. Okay, let me show you. You can see that this one is at right angles. Okay, the index fingers and the middle finger is at right angles. The thumb and the index finger is also at right angles. Okay, and the thumb and the middle finger is also at right angles. But this one I can't draw. Okay, I can't draw. But if you try to see from this side, okay, your eyes from this side, you see, okay, you will find that this and this, this and this, they are at right angles as well. So these three fingers, okay, are at right angles. So this one shows the magnetic field, and this one shows the currents, and this one shows the force. Okay, as long as you know the directions of the magnetic field and the directions of the current, then you can tell the directions of the force. So this is called Fleming's left-hand rules. When you use Fleming's left-hand rules, you must be careful. Okay, make sure that you use your left hand. Make sure that you use your left hand and don't use right hand, because we have another one called the Fleming's right-hand rules. Okay, Fleming's right-hand rules. So you must know when to use left-hand rule and when to use right-hand rules. Okay, left-hand rules we use when you want to find force. Okay, the left-hand rule is also called the motor rule. Fleming's left-hand rule is also called the motor rule. And we use Fleming's left-hand rule to find the directions of the force. Exercise 1. Use Fleming's left-hand rule to tell the directions of the force exerted on this conductor. Okay, this circle with a dot and this circle with a cross is the conductor. I will show you the first case, and then I want you to find the other 6. So let's go to the notes. Okay, forget about the hand first. Okay, forget about the hand first. So let's see the first case. Yeah, the first case. The very first thing is you must tell the directions of the field. Directions of the field. Now the field always move from north to south. The field always move from north to south. So the field is from north to south. The field is from north to south. Okay. Now this circle with a dot, it shows this is a conductor, okay, and it tells the directions of the current. If you see a dot like this, it shows the current come out from your monitor or it go inside the monitor. A circle with a dot come out or go in the current. Okay, if you see a dot, it's come out. If you see a cross, means it go in, it go inside. So this one, okay. So the current come out. The current come out. So let's use this hand. Okay, this hand. Let's rotate it. Okay. Now this one, it shows the current. This is current. Okay. The middle finger shows the current. The current come out, right? Okay. So we use this one. We do not use this. This one shows that the current go inside. So the current come out, and then the directions of the field. Directions of the field. Is from north to south. Okay, this one pointing downward. Okay, so then we can use this one. The current come out. The index finger shows the directions of the field. So try to use your hand to do this as well. Okay, yeah. Try to use your left hand to do this as well. Okay, so place your hand, okay, in these positions. Okay, so the currents come out from these monitors or the plane, and the field go down. And this shows the directions of the force, right? This shows the directions of the force. Means that the force will push this conductor to the right. The force will push this conductor to the right. And then the force is to the right. So that is how we determine the directions of the force. By using Fleming's left-hand rule. So in this case, the force will be is to the right. For this tree, is either to the left or to the right. And for this tree, it's either up or down. Yeah, up or down, because the directions of the force is always perpendicular to the directions of the field. Okay, so the field up, down, so the force must be left, right. Okay, now let's see the second case. So the field move up, right? The field move up from north to south. The field go up, and then the current go inside, right? The current go inside. So let's use this hand, okay? So currents go inside. The field going up, current go in, so the force to the right. Yeah, force to the right. Let's erase this. So the force to the right. Okay. And then for this one, again, the field go up, but then the current come out. The current come out from the monitor. So we use this one. But this one, we have to rotate it. Current come out, the field north to south go up, then the force is to the left. The force is to the left. So the force to the left. The last one, okay, this one. The field is from north to south, so pointing downwards, and the currents go inside. So let's use this one. And then rotate it. Okay. So the currents go in, the field is from north to south, pointing down, and then the force is to the left. The force is to the left. So the force to the left. So this shows the directions of the force. Then let's see the last three questions. Okay, so this one, the field is from left to right, and the currents go in. Okay, so the field go in. The field is from left to right. The currents go in. The currents go in, and the thumb point downwards. So therefore, the force is downwards. So the force is downward. For this one, the field to the left. So the field to the left, and then the current come out. The field to the left, the current come out, and the force also downwards. Downwards. So the force downwards. And the last one. So the last one, the field is from right to left, and then the currents go inside, and therefore the force pointing upwards. Okay, so this answer, okay, this answer. Okay, this is the advantage of using a computer, okay, because by using computer you can see the hand and the directions clearly. Normally in classrooms, it's quite hard for the teachers to show you all these directions, but when using computers, okay, you can see the directions clearly. Okay, after identify the directions of the force, then the next thing that you need to know is the factors that affect the strength of the force. The strength of the force. You can increase the current. The higher currents, stronger force. Higher current, stronger force. This usually is used to control the speed of the fan. The speed of the fan or the speed of motor. So usually we use this. So we increase the currents, then we increase the magnitude of the force. So increasing the current and use a stronger magnet. Okay, if you use a stronger magnet, then of course it will produce a stronger force. Use a longer wire. Use a longer wire. Okay, for examples, if this is a field, north and south, north and south. You can use a short wires like this, okay, or you can use longer wires, okay. Use a longer wire. So the longer wire will produce stronger force, stronger force. Okay. The last one is arranging the wire perpendicular to the directions of the magnetic field. Okay, this is important. So for example, this is south, and okay, this is north. If you place your wire like this, okay, if you place your wire like this one, like this, then it's perpendicular to the directions of the field. okay, is perpendicular to directions of the field. Because the directions of the field is downwards, the field's downwards. So this 90 degree, yeah? Okay. So if it's perpendicular to the directions of the field, then you can get the strongest force. You can get the strongest force. Okay. But if the direction is not perpendicular to the field, so for example, you put the wire, this way, then this angle is not perpendicular anymore. Okay, then the magnitude of the force that you get will be lower. If the wire is perpendicular to the directions of the magnetic field, then the force produced is the maximum. So these are the factors that affect the strength of the force produced.